So now we do the game where my slides go up. Woohoo! Gotta press full screen. All right. How's everyone doing? Good? So what I wanted to do today was talk through the state of the various CoreOS open source projects, kind of start where each project began, describe what the motivation was for each one, talk about where each project is going, make some guesses at where we'll end up in the next few months, and then finally encourage all of you to get involved one way or the other. The idea here was sort of to give a State of the Union. So at any moment, if you want to just give a standing ovation for an inappropriate long time, go for it. Please don't do that, please. I need to get my mouse back. Where is it? Okay. So I wanted to talk about first all of you that are here, all of you who are part of the community of people working on these open source projects and using these open source projects. Sort of what we're trying to build is things that you as a software engineer can interact with by taking your code and turning it into containers and deploying them, or you as an ops engineer taking those containers that have been built by your software engineers or yourself and deploying them to your infrastructure, your fleet of machines. And then also what I wanted to talk about was how you as a contributor can interact with the CoreOS open source projects, encourage more of you to participate in the discussions and things that happen around them. First I wanted to ask, who in the room has contributed to a CoreOS project? All right, so unlike other rhetorical questions, I actually ran the numbers on this. I did a join between the guest list and people who have interacted with our projects on GitHub. So that was only about a third of the people I expected. So somebody's lying. So if you've contributed, if you're a Choreo, anyone, like raise your hand if you've contributed. Filing issues, pull requests, great, thank you. And so if you raise your hand, you're one of about 800 people who've contributed to our projects in total, whether that be through your pull requests, through your issues, or through your comments. And it's been a great conversation that we've had over the last 2 years in that way. So what I wanted to talk through was some of the various CoreOS projects, CoreOS Linux, FCD, Flannel, and Rocket, and talk about where they came from and where they're going. So I'll start with CoreOS Linux. And one question that we get all the time is, well, why would you build another Linux distro? There's already 285 on DistroWatch under active development. And the motivation was that we wanted to have this server, this operating system that automatically updated and went from the white version of CoreOS to the slightly gray version of CoreOS, and did this in an automated manner. And we wanted to do it in a way that wasn't just a cron job interacting with a package manager, but actually was truly transactional. And so we never wanted to end up in this state where you're kind of halfway in between the old version and the new version of the operating system. And the reason this transactional property is really important is because if it's transactional, we can leave it to the robots to do it. We can leave software in charge of doing this rollout and this rollback. And it means that you never have to go into a server and say, oh no, what happened to my cron job that was supposed to update my server? And kind of reducing that complexity. And it's kind of a grand experiment in continuous delivery of a Linux server operating system. And we're able to get away with it by having a stable Linux kernel API. The promise of the Linux kernel, in most cases, is that it keeps its ABI promises and never breaks user space. And in order to make this work, we have to separate the OS from the application by using containers. It's a good best practice so that when we upgrade libraries, et cetera, we don't break those applications that are relying on the OS. And then we need to have a very consistent set of configurations so that when you lay down configuration, it's able to be upgraded, and there's not a lot of code that's running to configure the server. It's static configuration. Now, what we're trying to do, as Brendan Burns talked about during the Kubernetes talk yesterday was we're trying to kind of do the OS ops. So a lot of us spend a lot of time worrying about how do we deliver our applications in a continuous delivery way, where we're constantly rolling out new features, rolling out new security updates to our users. And in a similar way, CoreOS Linux, we'd like to deliver that same up-to-date freshness in the software that that delivers your operating system. And we've been running this experiment, this continuous delivery of OS experiment, for about 2 years. And we started with CoreOS Alpha that we introduced July 1st, 2013. We shipped our first beta almost exactly 365 days ago. We're 4 days off from that epoch date. And then 9 months ago, we shipped our stable release. And so we've been kind of rolling through all these versions of the operating system over time. And in that time, we've tagged a number of copies of CoreOS. We've tagged 329 copies of CoreOS. And this means we've done a few days of development, and we want to see if it is able to go through our testing and build infrastructure and have a working asset out of the back of that. And so out of all those images, we've probably shipped about a fifth of them. But we constantly are tagging and trying out and seeing if there's something that we can ship onto the alpha channel. And in that time, we've delivered 13 major versions of the Linux kernel. You can kind of think of the core of the thing we're building here as a Linux kernel delivery system. And over that time, we've delivered major versions of the kernel from 3.8 all the way through 4.0 a few days ago. And we've been working through all those major versions, submitting patches when we need to, that sort of thing. In a similar way, we've been delivering systemd. We've been contributing patches upstream to systemd. We've got about 30 upstream patches to systemd, and we're continuing to be involved in that community. And we've shipped 12 major versions of systemd through this lifespan of alpha to today. And people are using CoreOS in various ways. We heard from Gabriel from OpenDayas about how they use CoreOS inside of their project. Mesosphere uses CoreOS as the default operating system in the DCOS. People have built their infrastructure on top of it. I've heard from many of you who use CoreOS inside of your infrastructure for delivering your applications. We'll be hearing from Prakash from data.com later today about how they use it, and then also Robert from Coinbase after lunch. So some future work on CoreOS. CoreOS Linux isn't perfect, but we have a number of things that we're thinking about to make it better. The first is packaging a lot of what is the CoreOS stack inside of containers. So delivering things like etcd inside of a container instead of having that inside of the host directly. Supporting new architectures. So ARM64 has been something that people have been thinking about in the server space for a while. And we're starting to get ARM64 support landed in our SDK. And then finally, thinking about how can we do consistency and installation of server operating systems better. And Alex Crawford from CoreOS will be talking about a new project that we call Ignition that kind of does installation from the initRD. All right. So CoreOS Linux, we have a very poorly named repo called CoreOS/scripts. That's because this is one of the first Git repos that we built. And these are the build scripts that are used by our SDK. And in this repo, you'll find a couple of things. One is a contributing.md file. And you'll find this file in all of our major projects like etcd and CoreOS and Rocket. And this tells you how you can get involved, where you can find the mailing list, where you can find IRC channels. And also we have a roadmap.md file, which talks about what will be things that we're thinking about in the next few months. And so if you're looking for something to contribute, if you're looking to understand what we're building next, you can see these files for a rough idea of what's happening next. It made making these slides very easy. Just copy and paste from roadmap.md. So let's talk about etcd for a bit. So we built etcd around the same time we started building CoreOS. And the idea there was we wanted CoreOS on lots of machines. And we wanted those machines to be automatically updating, which is the whole reason for building CoreOS Linux. Unfortunately, we also, as system administrators, realized that if you're running out the door for lunch and then all your machines upgrade at the same time, that would be not so great. You'd get paged, your application is down. But your infrastructure would be more secure. So we needed to do something more intelligent. And so we built FCD to be as a way of controlling the rollout of updates. And so you want to roll out these updates one at a time through your infrastructure. And I got a little bored and didn't actually animate all that, but you get the idea. Like it goes through and rolls out the update on all of those. So this was the primary motivation for building FCD. It's one of our longest running projects, and it started, is Xiang in the room? Xiang? I don't see him. It started when we gave our first intern, Xiang, a bit of a challenge. We said, implement a consensus protocol and then a key value store on top of it and make that over HTTP and REST. Go. And we wrote the README file, so it was all implementation details from there, right? And it was kind of a big challenge, right? But over the course of a few months, about 4 months, Xiang and I, primarily Xiang, built the initial version of etcd that we released as 0.1. Now the project has grown. We see it used in a lot of projects and embedded in other systems. But how it works today with etcd as this kind of lock manager for your rollouts of updates is lots of machines are constantly asking etcd, hey, is it OK if I update to the latest version of CoreOS? etcd controls whether things are going to be allowed to update or not. Those things update, release the lock, and then kind of continues rolling out. And that's kind of the basic algorithm for how that works. All right. So the great thing about etcd is that this was the initial use case, but we've been seeing it used in lots of other projects. Kubernetes uses etcd. We talked about that yesterday. It uses it as a scheduling, as the backend for storing all the data about scheduling, service discovery, et cetera. It's kind of the primary data store there. And also will be used for master election of components since etcd is a consensus-based system, CP system. It can be used for doing master elections. So if a scheduler goes down or an API server goes down, a new one can come back up. Obviously, we used it inside of Fleet. Fleet is a scheduler system, and etcd backs that. It was adopted by Cloud Foundry's Diego. They use it inside of this PaaS system to control the workflow of taking code, transforming it into runnable assets, and some health monitoring. The new SF-based electronica artist, Vulkan, uses etcd. No, I'm kidding. It's just a really cool logo for a load balancer built by Mailgun. And they use Vulkan to load balance their API servers and be able to control adding and removing backends automatically. And then Yodler uses it for microservices and sort of service discovery in their own product. And we'll be hearing from Ross later today about that. And we see this a lot. People take etcd and use it for service discovery, master election of other databases, this sort of thing. And that's a great use case for etcd. So things that we can do better, things that we want to do next. The first is we're working through what we need for a v3 API of etcd. One of the first requirements that we've gotten from both Vulkan, from our own use case of Fleet, and from Kubernetes is the idea of multi-key transactions. So set this key and this key only if this key is at this current value or index. These sorts of transactions are necessary for making it fast and easy to do master election systems. And for other systems, like setting a schedule that has multiple moving components. Also read transactions, so getting a consistent view of the entire store at a period of time. People use the history of etcd quite a bit, sort of like a revision control system for all the dynamic configuration in your cluster. The next is we want to have a Diskback Store. This is so that we are able to hold on to history for longer periods of time. Today, etcd gives you the ability to look at what happened inside of the key store, but it doesn't give you the ability to look at that for very long. It's a very fixed window of time. And so we want to be able to give people the ability to look further back. And finally, we've been adding a lot of really punishing tests to etcd. We have a blog post that we'll be posting. Yi-Chin from the team has been working on this infrastructure that writes hundreds or thousands of writes per second into this very poorly managed etcd cluster where there's latency introduced and we're constantly killing nodes and that sort of thing to try to tease out bugs from the etcd cluster. And so there's a lot of interesting work happening there too. Now, one thing that I threw in after discussing with you all in the hallway track over the last couple, or after yesterday, was the need for a certificate authority. This came up after talking with CockroachDB. It came up, VMware is working on open sourcing a project around a certificate authority. People were asking about certificate authorities being used inside of etcd. Etcd supports TLS certificate authorities, but very few people use them. I think partially because it's kind of hard to manage the certificate authority. So today I wanted to maybe kick off a conversation about what our needs are for a certificate authority. What it sounds like is that we kind of need to build a new thing that's designed for clustered applications, like Cockroach, like Kubernetes, like etcd. And it needs to be API driven, and it needs to have external sources of truth. So the idea that a lot of these systems like Cockroach or etcd, you know that a new machine is coming up because you're able to talk to your OpenStack API, you're able to talk to your Amazon API and say, well, this machine I actually expected to come up, and so I should trust it implicitly. Obviously, that's not the default mode for this new certificate authority, but it's something that I think is pretty compelling, because the reason people don't use certificate authorities is because it's annoying to manage. It's like, I generate the secret, and then I need to take the secret down and sign it, and then upload the thing back up to the server, and it's just quite an annoying process. And then the last bit was some folks, while we were discussing the need around CockroachDB, was having a clustered version, because certificate authorities, by their very nature, are a centralized authority. It's called an authority. But we need it to also be available in the case of available in a similar way of etcd, so that if a couple of machines go down in the cluster, we're still able to do signing requests and audit the log of what happened. So some of the inspiration here, we built an open source thing called etcd-ca. It's a very poorly named project because it's actually a generic TLS certificate authority tool. We also built this prototype, an intern built this prototype a while back called Shortbread, and it was a SSH certificate authority. Anyways, I think there's a bigger discussion to be had here, and it's just something to keep in mind and something to think about. All right, so that's etcd. The next project is Rocket. It's our youngest project by far. It's an application container runtime, as you all know. And sort of the motivations that we had there was we wanted it to be a security-focused system, so that a system administrator, can actually manage the things that they trust. So do they trust CoreOS.com to deliver and run packages on their system? Or do they only trust their internal packages? Do they trust external packages? And being able to manage this trust was something that we wanted from the beginning. Because kind of what we think about is that we're building another version of package management. And it needs to have those same properties of being able to establish, revoke trust. It needs to fit into the existing process model so that people can integrate it with their existing systems. You can imagine that things inside of CoreOS, like log aggregators, system monitors, you want those things to just be running underneath your existing init system. And then finally, we wanted it to be able to support multiple processes. So this idea of a pod that Brendan talked about inside of Kubernetes, that's also very useful for system processes like etcd, where etcd may have the actual etcd process servicing etcd requests, and then also you want to back those things up to an object store like S3. And so being able to run those things together is a very natural fit. Now we've seen yesterday a demo of the Rocket plus Kubernetes integration. That's a perfect use case of Rocket. We built it not just with these system things in mind, but also with integration with existing clustering systems like Kubernetes. We also use Rocket inside of Tectonic for running the on-worker agents and also the control agents of the Kubernetes stack. So future work here is we want to be able to do better trust. So bootstrapping off of our existing SSL infrastructure so that there's not always that confirmation screen of, hey, yes, I trust this blindly, and nobody ever checks the fingerprint. Whoever checks fingerprints when they SSH into a server? 2 people, thank you. We should talk about the Shortbread project later. Also, we want to improve the image handling so that you can cat out individual files, delete images, etc. And then also pulling out the stage 1 from the Rocket build system and making that a first-class API inside of Rocket. So you can imagine not just using namespaces and C groups for containers, but also using a hypervisor like KVM as a containerization system inside of Rocket. All right, so along with containers, there's the need for container networking. Containers hopefully don't just live alone on a single lonely box with no Ethernet cable. And so along those lines, we've started to build the app container under the app container org, this new project called the Container Network Interface. And the Container Network Interface essentially defines how external plugins can set up a network namespace. So this would be things like setting up local networking configuration like IPVLAN or bridging on your host. CNI is already used in Rocket today. Essentially what we did was we had built a plugin system for Rocket, and then we talked to folks from the Kubernetes project and from Red Hat a little bit, and they had similar needs around kind of having an external interface for managing network namespaces. And so we pulled that out into a separate spec, and we've been iterating on that with a number of people from both Red Hat and Cisco's and others around how that actually works. And then the other piece of container networking is not just the local host configuration, configuring the actual namespaces on the kernel, but also how do we configure networking between hosts. And in a lot of environments, this is the best networking that we get. We get a single IP address for a single virtual machine or cloud machine or physical host or whatever. But what we really like is for each individual container to be able to address and talk to each other over a shared IP network space. And so along those lines, we talked downstairs yesterday about Flannel, which is our project to create a really simple overlay network for these container systems. And Flannel coordinates through FCD to set up routing tables and sort of do leasing on subnets. And the system works very similar to other things that work through FCD, and it has very similar properties. But the basic idea is having this routing table that's set up. And the future work here on Flannel is that we'd like to have a Flannel server, so abstracting Flannel away from the talking directly to etcd and being able to put authorization and authentication on that API. And we've been thinking through how that separation allows us to integrate with the authentication and authorization framework inside of Kubernetes, because it's very similar. You're consuming resources off of the network. It's giving you information about the cluster, so you should have the same authentication and authorization around that. And then one of the other pieces that's been a to-do for 5 months, and it'd be a great starter project for anyone who likes networking, is adding generic UDP encapsulation support. Currently, Flannel tunnels over VXLAN and a user space tuned tap device, but this would be a really interesting one. There's an issue up on GitHub about that. And then similarly, there's a project, Project Calico, that does networking. It coordinates through etcd in a very similar way, but with a different use case. And we'll be hearing a talk about that around 2:20 today on this stage, actually. So what I want all of you to do is, if you're a user of our systems, I want you to reach out on IRC. I'd love to hear your use cases on the CoreOS user mailing list. Help out by testing the latest CoreOS alpha. These are the conversations that I've had here have been really fantastic, but I'd like them to continue even after the conference, because the feedback that we get, like we got extremely honest, kind of brutally honest feedback from Gabriel yesterday from the OpenDAS project about what's working well and what's not working well inside of CoreOS Linux. And this only works if we have a good feedback loop. And then also you as a contributor, looking through our roadmap files, looking through our contributing files, and sending pull requests, reviewing pull requests, participating in a lot of the discussions. A lot of our discussions can be a little long, but the input ends up with a better solution once we all agree on what we're actually trying to solve. And for some inspiration, I wanted to walk through a few people, most of which are here today, about things that have been done in the last few months that are really cool. So Jeff works at Huawei, and Jeff did the initial introduction of ARM64 toolchain support and sort of inside of the CoreOS SDK. So I want to thank Jeff if he's here. Woohoo! Thanks, Jeff. Ben Darnell, who is standing right there, he works on CockroachDB, and he's been contributing a number of things to the Raft library that we initially used inside of FCD. We talked about the multi-node and the heartbeat separation yesterday, but he's been also helping out on just bigger design questions inside the Raft library. So I really appreciate all of Ben's help, and thanks for all your work. All right, and the last person is Monet, who is not here. But Monet was a very early contributor to the Rocket project, and so much so that we thought that he was working full-time on it, and none of us were like, does he work full-time on this? I don't know. He was contributing just massive amounts of code, and he was constantly rebasing and working with us, and it's been really fantastic working with him. He's been doing this all in his spare time. He's just extremely productive. And so he built and improved the image store and the tree store, the cache of the actual extracted images for Rocket runtime. He's also refactored the entire fetching system, so how we download images over the internet and verify their signatures. And then also he did, most recently, work on how we migrate from one version of Rocket to the next, because we have this internal data store that kind of indexes all the container images that we have on disk. And he worked on all those SQL migrations. So thanks so much. It's been awesome working with him. All right, and so last off, you've seen these posters around the conference. There's been a ton of people contributing to our projects. These are just highlighting a few extremely notable and dedicated folks. But it's been really great to work with all of you, and I'm looking forward to the things that we can build together. And with that, I want to say thank you, and I'll take some questions.